Hello and welcome to another week of Foundations to Computing. This week we're going to be talking about computer networks, and right now I'm just going to give you a very broad overview of all the different topics that we're going to be talking about this week. So this week we're going to learn about how computer networks work, what they are, the network layouts, communication devices that are used for networks, and more. So first of all, I'm going to broadly go over 3 different types of network communication styles that we use. So the first one is going to be, let's cover what a network is. So a network is a group of computers that use a set of common communication principles over digital interconnections for the purpose of sharing network resources or resources in general located on or provided by network nodes. Okay, so we all know what a computer network is. It is that thing in your home that connects all the different devices up. Office buildings have them, cities have them, they're everywhere. So the first kind that we're going to go over in this class is an LAN, or a local area network. These are the networks that connect up everything inside of an office building or inside of your home. These are very concentrated. There's a reason that we're using the word local. So this is going to be your local area network. That's going to be everything inside one area, one small area. The next is a WAN, or a wide area network, and that's going to be everything that's located in like a city or from state to state. As a matter of fact, you can even consider the internet to be a WAN. It's a wide area network connecting up multiple LANs. As a matter of fact, when I worked at a company called WEX, I worked in the Ogden office, but there was an office in Salt Lake, another in Portland, Maine, another in Kentucky, and many more. And all of these offices had their own local area networks, or LANs, and they were all connected together. And what we would call them when they were all connected together would be a WAN, or a WAN. So that is an example of a wide area network. Next we have a MAN, so that's a metro area network. Now a MAN is going to be the same thing as an LAN or a WAN, only this one is going to be concentrated in a city. Hence the name metropolitan or metro area network. It's the same idea, just a smaller version of a WAN, a smaller version of a WAN and a larger version of an LAN. All right, so now we're going to go over different types of media, or ways that the transmission of data actually happens. And the first thing that we're going to go over is the guided media. And guided media specifically, we'll be talking about wires and different types of wires. So the first wire that you're going to need to learn about is a coaxial cable. This is a copper wire. You're probably familiar with this from watching it being plugged into your internet or digital service in the wall. You have to kind of twist it in there. So this one, the way it's built is with copper wire. And so coaxial cable is a type of electric cable consisting of an inner conductor surrounded by a concentric conducting shield. So there's a lot of technical language in there. You'll want to dig into that in this chapter so you can understand how this wire works. But at the end of the day, it transmits electrical signals. The UTP, or the unshielded twisted pair. So you've definitely seen one of these. This is what is going to be common for plugging in your internet using the Ethernet. Phones also use these. It's another form of wire that is copper wire, and you twist the wire together, and that twisting is supposed to help the wire to not have any noise or a reduction in data because of obstructions. And finally, we have the fiber optic cable, and now this one is really cool. It's the bundles of glass surrounded by plastic and transmits data in the form of pulses of light. So this glass sends light across the cities and wherever these wires are. They are so neat, but they are specifically made for long distance transmission, and it is because they are resistant to attenuation. Now, what is attenuation, you may ask? Attenuation is the loss of signal strength in networking cables or connections. This is typically measured in decibels or voltage and can occur due to a variety of factors. It may cause signals to become distorted or undiscernible. So if you look at this little image we have right here, this would be if the signal was going through just strongly, and then this is where, as you can see, it's kind of getting smaller. So that's what attenuation is. It's just the signal weakening as the length of it gets longer and longer as it's traveling a further and further distance. And this is a real problem in networking. This is something that we've had to try to figure out how to deal with. So we've come up with several ways to deal with them, fiber optic cables being one of those ways. We've also figured out how to deal with them regarding unguided media. And unguided media is, let's just look at the definition here. It says the transport of electromagnetic waves without using a physical conductor. This type of communication is often referred to as wireless communication. And we all know what wireless communication is. That's going to be your Wi-Fi, your Bluetooth, your satellites, so anything that's broadcasted through the air. One of the first ways that we are going to talk about unguided media being set up is through the WLAN, or the Wireless Local Area Network. In other words, this is going to be how your Wi-Fi is being connected. So a wireless LAN is a wireless computer network that links two or more devices using wireless communication to form a local area network within a limited area, such as a home, school, computer, laboratory, campus, or office building. So it's just like a LAN, so a local area network, only we're also using the emission of signals and waves to get our data transmitted. All right, Bluetooth is the second form of unguided media that we're going to talk about, and we are all familiar with Bluetooth. We use this in our phones with our headphones. It's a wireless technology standard used for the exchanging of data between fixed and mobile devices over short distances using short wavelength, ultra-high frequency radio waves. And you're going to want to dig into Bluetooth and kind of get a better idea and better picture about what it is. It's a really neat technology used as an unguided media commonly nowadays. And finally, we have satellites. So everybody's heard of broadband. Everybody's heard of satellite internet. So, everybody has that friend that has a satellite internet box that they can carry around. They get satellite internet out of it. So satellite is a machine that is launched into space and moves around Earth or another body of space. That is what technically a satellite is, but we use those to broadcast internet and data and phones. There's lots of different things that we use satellites for, but those are primarily what they are used for. All right, let's talk about protocols. Why are they important? What are they? Protocols are rules for communicating over a network, and we're not going to get too terribly deep into them today, but we are going to cover them in a little bit in this section. So HTTP, Hypertext Transfer Protocol, that is the protocol we use for communication over the web. You've probably seen that in your URL bar on your browser. So it's letting your browser know that we're using HTTP, Hypertext Transfer Protocol, to send our data. Yes, there are other ones, not just HTTPS. There's lots of ways to transfer data. Protocols, remember, they're just rules for how we're going to transfer data. We're trying to communicate to whatever tools we're using how we're going to get that data transmitted to the next place. POP3, so Post Office Protocol. It's an internet standard protocol used by email clients to retrieve email from a mail server. POP version 3 is the version in most common use. And if you take a look at this image here, you'll see that we use SMTP, another internet protocol for a protocol for sending emails to actually transmit the data. And then we use that POP3 or IMAP, that's another one, in order to download that data onto your device through some sort of application like Outlook, or I know Apple has Apple Mail. So that's what you use is POP3 or IMAP in order to get that communication onto your device. All right, so let's jump into the famous OSI model. What is the OSI model? This is awesome and very exciting. The OSI model is the Open Systems Interconnection. It's a 7-layer architecture, with each layer having specific functionality to perform. All 7 of these layers work collaboratively to transform the data from one person to another across the world. Okay, so I'm going to read just a little bit here so we can get kind of a better overview, okay? So the OSI model is a conceptual model created by the International Organization of Standardization, which enables diverse communication systems to communicate using standard protocols. In other words, the OSI provides a standard for different computer systems to be able to communicate with each other. So this is a conceptual model that the standards people, the smart people who have gotten together and said, we need a standard, they've gotten together and they've created this OSI model. Now, it's conceptual, and every single layer on this model does not apply every single time there is a transmission of data across a network. However, this is a really thorough and a model. It covers all layers that are possible. So let's start talking about these layers. So there's application, presentation, session, transport, data link, and physical. Now these are all the layers, and we're going to go through them very quickly here so that you can have a deeper understanding of what these layers mean and what do they have to do with a network. I do believe that you should try to memorize these. It will help you with any quizzes that you might take. It will also help you in your computer science career. Anybody who's in computer science is going to be using one of these layers or referencing one of these layers at some point in your career, especially if you're interested in a networking career or a cybersecurity career. So you're going to want to memorize these. And so I've provided this mnemonic here, and this mnemonic, all people seem to need data processing, seems like a cute mnemonic to me. Maybe it will help you memorize these. All right, so here we have the application layer of the OSI model. So this serves as a window for the application services to access the network and for displaying the received information to the user. Some examples are browsers or Skype Messenger or, iMessage. So application layer is also called the desktop layer. One thing that should be understood is that software applications are not a part of the layer. Rather, the application layer is responsible for those protocols and data manipulation that the software relies on to present meaningful data to the user. So that's kind of the closest it gets to you, is this layer right here. The presentation layer, also called the translation layer. So the data from the application layer is extracted here and manipulated as per the required format to transmit over the network. So it's encoded or decoded. So the presentation layer, that is where your data is going to be encoded or decoded depending on if it's coming or leaving. So the session layer, this is responsible for the establishment of connection, maintenance of sessions, and authentication, and also ensures security. So this session is basically going to open you up a session. Pretend you have a computer over here and a computer over here, and they want to have a phone call. Well, this would be like the phone call being made and that connection is now established. Once the computers hang up or the people hang up, that session is no longer established. So that's the session layer. So transport is the heart of the OSI model. It is responsible for the end-to-end delivery of the complete message. The transport layer also provides the acknowledgement of successful data transmission and retransmits the data if an error is found. So basically what happens is your data is broken up into all these millions of little tiny pieces and it's sent across the network. Well, the transport layer is responsible for making sure that all those little tiny pieces of data end up all at the right location in the right order so that you can have, streaming or just any information that you have on your computer because of a network, because of the internet. All right, so here we're at a network layer. This is our first hardware layer. Remember, we're talking about the OSI model. We are on the fifth layer of the OSI model, and this is the network layer. It's responsible for the transmission of data from one host to the other located on different networks. It also takes care of packet routing, i.e. the selection of the shortest path to transmit the packet from the number of routes available. So the network layer is responsible for facilitating data transfer between two networks. If the two devices communicating are on the same network, then the network layer is unnecessary. So this is if you have, a WAN and you are trying to get communication from one LAN to another LAN, right? Not if you're only on one LAN. If you have just on that LAN, this network layer is not necessary. But this network layer is responsible for the transmission of data from one host to another. Data link, this is another hardware layer. So this is responsible for node-to-node delivery of the message. The main function of this layer is to make sure that the data transfer is error-free from one node to another over physical layers. So the data link layer is very important. It's similar to the network layer, except that the data link layer facilitates data transfer between two devices on the same network. Okay, so if you have an LAN, this data link layer is what's going to be dealing with those transmissions of data. And they're going to be dealing with, the routing and how is it going to get to the right computer, and the same with the network layer. Finally, we have arrived at the seventh layer of the seventh and final layer of the OSI model. Remember, OSI stands for Open Systems Interconnect. Okay, the last layer here is the physical layer, and this layer includes the physical equipment involved in the data transfer, such as cables and switches. This is also the layer where the data gets converted into bit stream, which is a string of zeros and ones. The physical layer, both devices must also agree on a signal conversion so that the ones can be distinguished from the zeros. So this is the final layer of the OSI model. Congratulations, if this is your first time hearing about it, get ready to hear about it for the rest of your computer science career, because this is a very common conceptual model used in many conversations. Awesome, let's talk about network topology. So network topology is the arrangement of elements of a communication network. They can be used to define or describe the arrangement of various types of networks. So this is going to be how we arrange the communication on the network. Configuration or topology of a network is key to determining its performance. Network topology is the way a network is arranged, including the physical or logical description of how links and nodes are set up to relate to each other. And real quick, in case you don't know what a node is, it's basically any computer or device on that network. So that could be a switch, a router, a hub, a computer, an iPhone, and we'll get into the switch routers and hubs in a minute here, but I just want to let you know that might be a node on the network. So, but for now, let's just focus on the different designs that we have potentially for this. The first one that we're going to talk about is a bus. So this is where there's a main cable, and all the devices that are connected to it are connected through this main cable and through some drop lines. This is also sometimes called line topology or the backbone topology. Bus topology is very cost effective, and it's great for smaller networks. But because it's for smaller networks, it can break, which is cause cable failure, because we're all just depending on this one line. And sometimes if you have a small network, it's not that big of a deal to get that fixed, but if you have a large network, that can be very time consuming and expensive. So this is great for small networks. Here we have a ring topology. So this is where each device is connected with two devices on either side. There are two dedicated point-to-point links a device has with the devices on either side. The data can travel through the ring network in either one direction or both directions, with each device having exactly two neighbors. So one positive thing about topologies are that they are cost-effective as well as like the bus one, and expensive to install. And the intricate point-to-point connectivity of the nodes makes it relatively easy to identify issues or misconfigurations on the network. One negative is that the ring topology would be the entire network must be taken offline to reconfigure it. So that's time consuming, that can be expensive because they're all connected, right? So you can't just disconnect one, you got to disconnect them all. So that is the ring topology. So again, real quick, just wanted to sum up, when we're talking about topologies, just think about your last computer class that you were in, where you were all at your own computer desk. Those computers were connected somehow, and they were connected in some sort of topology. Probably a line topology is what I would think. Or a bus topology. So finally, let's talk about a star topology. Each device in the network is connected to a central device called a hub. We'll talk about a hub in a second, but a star topology is laid out so that every node in the network is directly connected to one central point through a coaxial, twisted pair, or fiber optic cable. The central node manages data transmission, as information sent from any node on the network has to pass through that central one to reach its destination. So great, that is all we're going to talk about for topologies. Good job, we've gotten through bus star and ring topology. So now let's talk about all the different network devices, and we have a lot to get through, so we're going to plow through these. So what is a network communication device? It is any type of hardware capable of transmitting data instructions and information between a sending device and a receiving device. If you have, kind of like how we have a post office mail person, mail truck, mail boxes, and soon we'll all have mail drones. Well, our network needs tools to accomplish these nuanced tasks of networking. And these devices help us to do that, just like those different mail devices or tools or people I just mentioned are used to transmit mail. So the first device that we're going to talk about is a network interface card. And this is a computer hardware component that connects a computer to a computer network. It's really that simple. It's a little circuit board that every single one of your computers has, or your cell phones, your smartphones, they have in order to connect to the internet. Without this, it cannot connect to the internet. This is how your device is able to do that. Here, let's talk about a repeater. So a repeater is a network hardware device that receives a signal and retransmits it. It's used to extend transmissions so that the signal can cover long distances or be received on the other side of an obstruction. A repeater is used kind of like how I was talking about attenuation earlier in this video. So attenuation is a real problem if there is a long distance for the data to go. That repeater is just going to repeat that information so that it's just as strong by the time it gets to the other node on the network. A hub is a network hardware device for connecting multiple Ethernet devices together and making them act as one single network. Now the thing about a hub is it's going to take in any information that it receives and it's going to broadcast it out to every single one of the lines that are connected in. It's almost like a multiple port repeater. So that is very useful in retransmitting data and getting that data throughout all sorts of different devices. In contrast to a switch, so people like to compare a hub and a switch. Now a switch is a network hardware that connects devices on a computer network by using packet switching to receive and forward data to the destination service. So it's similar to a hub in that you plug in all of your computers and devices. However, it's different because it does not rebroadcast that signal to everybody. Not everybody on the network gets everybody's data. Instead, this switch guy, this little awesome device, what it does is it figures out where those packets of data are supposed to go so that you don't have to continually broadcast them to every one of the people who might be connected on the line, or every one of the computers that are connected to the line. So that is the difference between a hub and a switch. All right, here let's talk about a bridge. So network hardware that connects two or more different LANs, and both have similar protocols and provides communication between the devices in them. So a network bridge joins two separate computer networks. The network bridge enables communication between the two networks and provides a way for them to work as a single network. So we have a local area network over here, a local area network over here, and we use a bridge to connect them so that they can be one. A larger local area network. All right, a modem. You've all seen a modem before. You have to have one of these in your house probably. A modem supplies access to the internet through an ISP, internet service provider. It establishes and maintains a dedicated connection to the internet. So there are two types of signals that are used for your internet and computer communication. One for the computer and one for the internet. Computers use digital signals, and the internet uses analog signals. Now, this modem modulates and demodulates those signals. And so the job of the modem is to demodulate the analog signal from the internet so that the computer can understand the incoming data. And the modem will also modulate outgoing signals. So it demodulates the incoming signal and it modulates the outgoing signal. So it's like a translator. A router, a network hardware that receives and sends data on computer networks, sometimes confused with hubs, modems, or switches. However, routers can combine the functions of these components and connect with these devices to improve internet access or help create business networks. So routers are complex devices. They're very cool. They're very smart. We've all seen one of these. Sometimes your modem will have a router in it. They're responsible for receiving, analyzing, and forwarding data packets among connected computers in a network. And I'm going to have you watch a video to discern what the difference is between a router is and I think there's one of the other ones, access point, firewall, or gateway. One of them you're going to see, and seeing the difference will help you understand what a router is and does in comparison to all these. All right, an access point. A wireless access point, or more generally known as just an access point. It is a network connecting hardware device that allows Wi-Fi devices to connect to a wired network. So essentially, your router has an access point in it usually. So if you have a modem that has a router, it'll most likely have an access point within it as well. Sometimes, however, they don't have that access point, or maybe you want to extend the reach of your Wi-Fi, and so you'll plug it into the Ethernet, and you'll be able to pull your Wi-Fi to another area of your office or school. These are generally used in larger facilities. Usually a house is not going to need one of these. This is going to be more for businesses or schools. All right, we have 2 to go. We have firewall. So this is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Typically establishes a barrier between a trusted network and an untrusted network. So everybody's heard of a firewall before. These can be software or hardware, but usually they're software, and usually actually your router is going to have a firewall, and it's basically just going to monitor incoming traffic to make sure that it is legitimate traffic, that it's not someone trying to hack your system. These are specifically for security, and as you probably are aware, most firewalls and routers are very secure, but your computer does come with one if you ever do wish to have extra protection on your computer. Finally, we're going to talk about a gateway. It's a key stopping point for data on its way to or from other networks. A router is a common type of gateway used in home networks. It can connect a computer of one network to another and define the boundaries of a network. So if 2 networks of different kinds of protocols want to connect to each other, both networks need to have gateways which provide exit and entry points for computers from 2 networks to communicate. So essentially, it's like the bridge that we were talking about, only it's smarter. So it's going to have more router capabilities, and it's going to have be able to connect 2 different local area networks together to create one larger network. Awesome. So I've officially finished briefing you on these topics. Please spend the remainder of your time this week looking through the corresponding articles and videos to gain a deeper insight into each of these topics. Then complete your computer networking assignment and quiz. And don't forget to watch the HTML tutorial. And I will see you guys in the next one.